Use the HVAC temperature rise formula to calculate airflow cubic feet per minute with precision by locking in a stable temperature differential and verifying it with repeatable readings before you touch the math. Set the furnace to heat mode and let it run long enough for the heat exchanger and ductwork to reach steady state, usually 10 to 15 minutes under continuous operation, because airflow cubic feet per minute from temperature rise only works when temperature differential is steady. Measure return air temperature and supply air temperature as close to the equipment as practical upstream and downstream of the heat exchanger, using matched, calibrated thermometers or a fast response thermistor probe with at least 1/10 of a degree resolution. Place the return probe in the mixed air stream, not against metal, and the supply probe in the center of the plenum away from the heat exchanger surfaces to avoid radiant bias. Take 3 consecutive readings at 30 to 60 second intervals. The temperature differential is stable when those numbers change by no more than half a degree. Record the furnace input in British thermal units per hour from the rating plate, then calculate delivered heat by multiplying by combustion efficiency if measured. Otherwise, use nameplate steady-state efficiency and note the uncertainty. Measure total external static pressure and verify blower speed tap and fan table airflow estimate as a cross-check. Temperature rise airflow should be within about 10% of the fan table value. Use the airflow formula. Airflow cubic feet per minute equals output British thermal units per hour divided by 1.08 times delta T for standard air. If air density is off due to altitude or unusual humidity, correct the 1.08 factor by using 1.07 times air density ratio. Recheck that delta T falls within the furnace nameplate rise range. If not, adjust blower speed to bring rise into spec and repeat the stability check before trusting the airflow number. One of the top mistakes in airflow measurement with the HVAC temperature rise formula is taking readings before temperature differential stabilizes, which skews airflow cubic feet per minute low or high. Fix it by waiting for steady state, confirming 3 repeatable temperature differential readings within half a degree, and avoiding measurements during stage changes or defrost. Another common issue in temperature rise testing for airflow is bad probe placement and contact error causing radiant or conductive bias. Fix it by using an immersion-style probe in the airstream center, shielding from radiant heat, avoiding metal contact, and sealing sampling ports to prevent room air dilution that ruins delta T accuracy. A third frequent problem in calculating airflow using temperature rise is using nameplate input without verifying delivered output and ignoring altitude and air density corrections. Fix it by clocking the gas meter to confirm input, measuring combustion efficiency with a proper analyzer when possible, applying density corrections to the 1.08 factor at high elevation, and validating results against blower performance tables and total external static pressure. BigHomeProjects.com hosts a vetted directory of heating and cooling pros who follow best practices for airflow testing, temperature rise stabilization, and accurate cubic feet per minute verification. Homeowners use it to find trustworthy local contractors, while contractors use it to showcase credentials, earn verified reviews, and get steady work from people who need precise HVAC diagnostics and installs.